Hello everyone, Blind Man Bert here, and welcome especially to you, Paula, who just asked me, what is this? When I was referring to how my girlfriend Shauna had just discovered the night sky using Stellarium. And I referenced a link to stellarium.org. I said, Shauna has discovered the night sky via Stellarium 0.20.4. And then I showed a view of the night sky, and here's where actually wasn't the night sky, it was the daytime sky. Here's where I should probably shift gears and share with you all what the current day sky looks like here in lovely scenic Prescott, Arizona. So what you are currently seeing is a simulation of what would be in the sky right now, looking kind of, the sun rose from here and Venus is being dragged along with it. Let me zoom back a little bit. It helps to have a nice computer with that can pump out a lot of frames per second, like this iMac i7, even despite the fact that I'm recording this video and audio, it's pumping out a nice solid 38, 37 frames per second, which is pretty decent. So basically I was saying Shauna, my girlfriend, has discovered the wonders of this program, Stellarium, which you would call a sky simulator. It basically can take you forward and backward in time, can take you to any place on the planet. You know, we can look at what's up in the sky right now, and this is not exactly an accurate rendition in that you would tend to want to see the ground, okay? This is just a simulated ground, and you would also tend to want to see what through atmospheric scattering things look like. So things actually get very, very boring. And also these stars, you wouldn't be able to see either. So this is actually, and you wouldn't be able to see the ecliptic plane, but I'm going to leave it there for now because it's actually kind of hard to disable. So this is actually probably more representative of what you'd see. So you look around and we're just seeing basically a very boring, it's kind of boring what you see during the day because of the fact that the atmosphere caused by the sun just blots everything out. But from an astronomical perspective, simulation-wise, we could turn off the ground, making it essentially transparent, and also turn off the atmosphere, and we can see these things. And what's really great is we can start to look at these things close up. Don't look directly at the sun unless it's a simulated sun, in which case we have no problem looking at it. Venus is tremendously close to the sun and behind it. And I'll explain how we know that it's behind it. We observed that Venus is almost completely lit right now. If I don't have it turned on, but if we looked at the additional information available about Venus, we'd see it's like 99.9% illuminated. There's just a tiny sliver of darkness here. That would, if you think about it, indicate that it's further to the sun from us than in front of the sun. If it was closer to us than the sun, then it would actually look very much like what the moon looks like right now. And I'm going to have to go find the moon. Where's the moon? There's Uranus, so I know the moon's a little further than that. There we go. Here's the moon. The moon is actually, if you think about it, obviously closer to us than the sun, because it's only about 1/8 of a million miles away as opposed to 93 million miles away. And you can see that being closer to us, it's primarily lit on this side side facing the sun, and it's primarily not lit. So we can look, see here again, I'm not seeing the illumination here, but we can install this great program available for Mac and Linux and Windows systems for free. Just go to stellarium.org and you can go around and putz around and see these things. And the most exciting thing right now, and this is a little hard to explain, I'm going to an extreme wide angle lens mode right now. First of all, you could go to this type of view, which looks really strange, but let me explain what you're seeing here. I can't for some reason, it's because I have the, I need to have something in the zenith. Yeah, here's the zenith, see that Z, green Z. Can't quite click the zenith, but maybe if I search for Polaris, which is very close to the zenith, I can do what I'm trying to do. We're going to center the North Star. Oh wait, the North Star isn't at the zenith. The North Star is at the North Celestial Pole. In any case, I'm just going to pick a star kind of close to straight up. Oh, here's straight up right here. So let's go just pick a star very close to straight up. Look at how deep this star catalog is too. This is great if you want to, you know, look at astronomical things. You can see how everything's moving right now. There, I picked a bizarre star that's pretty close to the zenith. And now if I go back, what I end up here, if I turn the ground back on, is what's known as a star chart. So this is kind of showing us, let me stop time so it stops spinning. This is what's known as a star chart, and I'm only using the ground here to blot out everything that we can't see. If we were to lay on our back and look straight up at the zenith, we would see everything from, here's north at 0, I'm putting it to the top, north at 0 degrees and east at 90 degrees this way, right? North would be behind us. If we laid down straight, so north was above our head and east was the direction our left hand was moving. Remember, we're laying on our back looking straight up, and south was at our feet, and west was at our right hand. Essentially our body forming a compass of sorts, our head being 0 degrees, left hand being 90 degrees, feet being 180 degrees, right hand being 270 degrees. This would be a star chart or sky chart of what's in the sky right now. And it's boring. It's extremely boring because the way it actually looks is basically just like this. You don't see all the wonderful variations of things that are in there. The thing that's occurring right now in the daytime sky, and you see a piece of it each evening in dusk, is people got really excited about the Pisces new moon. In any case, in every month, there's both a new moon and a full moon, sometimes two. And you call it a blue moon if it's a full moon in the US. So that kind of corresponds to, there's a new moon and a full moon to each astrological sign. So it's not really a big deal that there's a full moon or a new moon in Pisces. It just so happens that the Pisces new moon sometimes aligns pretty closely to the equinox, the point in time when the Earth is neither pointed away nor towards the Earth from either hemisphere. It's kind of equally lit, if you will. That's not what excites me about this time. There's something I refer to as the string of pearls phenomenon, where let's actually back up time. Let's back up time, which is great. We can actually take what's in the sky and move backwards. And remember, this is not a realistic view. So now if I put a time clock up here, we will see that relative to Prescott, Arizona's local time, we're moving back in time. Let me take you through very quickly in very gross steps what's kind of cool about this sky. First of all, there's a few invisible things that rise first. If I turn on my constellations, again, this would actually be very accurate. This is at not quite here. Let me move it forward a little. Let me just actually set it to exactly 5 a.m. this morning, March 19th. You can see we can do that very easily. We see that Sagittarius, the constellation Sagittarius, is here. And let me turn on a couple other things like the artwork for Sagittarius. Sagittarius is this big mythical, I don't even know what you call that, a centaur or something that's basically shooting an arrow. But actually in the United States, we tend to think of this asterism. Asterisms and constellations are very culturally, but in the United States, we tend to think of this asterism, the teapot. You can kind of see the teapot here with I think of it as having an arm coming off this way, and I kind of do it like this. I kind of go, and that's my teapot imitation. Anyway, the center of the galaxy, which is presumed to be inhabited by a supermassive black hole, is right around here. And if I search for, that's actually something that Sean and I are studying right now in our little afternoon and evening study sessions. Sagittarius, a star, which if we zoom in is right there, is a radio source, which is believed to be the very supermassive black hole. Otherwise, I call it a super hole, estimated to be about 4.5 million solar masses smashed together in a tiny, tiny little space of less than 10 million miles. And basically, you don't want to be anywhere near that thing, and stars going around that whip it around it really quickly, which is how they know it's there. So that's the first invisible thing that you see in this panoply of morning things, is something actually kind of invisible, which is kind of cool. And then the second invisible thing, and this starts all of the planets, is Pluto, which I can't, I'd have to get further in for it to be highlighted here because it's so dim. But somewhere in here, in this neighborhood, is Pluto before Saturn. And the better way I can find it is just to simply search for it as well. Pluto, remember, was demoted. There it is. So the label doesn't even come up until we're really close to it. It's such a dim thing. So there's Pluto, and this is actually a pretty accurate rendering from pre-New Horizons flyby. We have far more resolved images that are not being shown here. But this is basically what Pluto looks like with its configuration of stars. So it's actually time correct as to where Pluto and Charon are. And it's important to realize also that there's a longer video I made where I looked at the masses of Pluto and Charon, and there's a good argument to be made that Charon is not really a moon of Pluto, but something was probably captured, and they're co-orbiting. They captured each other. Very romantic, because I think Charon is about a quarter of the mass of Pluto, which is very rare for a moon. And then these other smaller moons are probably things that indeed were not created by accretion, which is how normal terrestrial moons or gas giant moons occurred, but probably small captured things as well. So there's Pluto hanging there. Again, quite invisible unless you're at a very, very, very large telescope with very, very skilled people. And forget about seeing Sagittarius A star. That you have to look so directly through so many billions of miles or trillions of miles, quadrillions of miles, however many miles it is. I don't even want to think about how far you have to go. You have to look through so much dust and gas. It's virtually impossible to see there, except with the latest adaptive telescopes working in the infrared domain, which do pretty good at cutting through gust and DAS, or otherwise known as dust and gas. So then we start to see some actual things that you can see both with the naked eye and binoculars and a telescope. For example, Saturn. So here is Saturn. Basically, we see Saturn here in its orientation the way you would see it if you were to look from Prescott at this thing. You would see it just oriented like this with its principal moons like that. In my telescope, I just kind of see it as a thing with a bulge. I can't really see the moons. I don't have my little $135 telescope isn't really enough to resolve the rings and see the moons. But that's not true of Jupiter. If I go down and I now look for Jupiter, which is down here somewhere, or I could zoom out a little bit more and find it that way. Jupiter, as of 5 a.m., I believe was just coming. Wow, that's way down, huh? I have to, yeah, see, there we go. Jupiter at this time was so far to the horizon, I wouldn't be able to see it. But this shows where it is, at where all of its Galilean moons are principally. This is a star. This is not a moon of Jupiter. But we see Jupiter here, and then the closest moon is Io, slightly on the reddish side. Then we have behind it Europa. So Europa we can't see right now because it's actually behind it. Then out here we have Ganymede and Callisto. Those are the first four Jovian moons. And those look just fine in my telescope. And I haven't adjusted this program for my telescope, but there's a way of setting these controls up here, which I haven't done yet. I haven't fine-tuned it. So you can tune it to your actual telescope or binocular viewfinder. These two visible things, Saturn rising at, we can get the rise time here, at 4:24 this morning in the past, and Jupiter arising at 4:57 a.m. are just the first two of a number of things appearing. And now let me turn on the atmospheric effects again. Let me get rid of this clock because it's in the way. Here we see the atmospheric effects coming in. So it's already kind of hinting that you won't be able to see all the stars. Did you notice how a lot of the stars disappeared when I turn the atmospheric effects on. But basically, it's still pretty dark. You'll be able to see these two things. And unfortunately, from our vantage point, from Shauna's balcony, our optimum, though incredibly light polluted spot, there's a big building in the way, so you can't see this. Another notable target right here is you'll think when you first look at this that this is Jupiter because it's pretty darn bright. No, it's the star Theta Capricorn, which probably has a name, but it's not showing up here. So the order of visible things appearing is Saturn, then Theta Capricorn, then Jupiter. And then if we continue playing, those are satellites all whizzing by, which, yes, are accurately rendered and tracked. So you could find out what each of those things is. If we just basically play forward, we're now up to about 5:20. Dawn is coming on. Now we start to see a few things. Neptune appears very close to when the sun rises with Venus. And here I'm going to turn off. Oh, actually, yeah, Mercury comes first. So for us, a very challenging target will be to spot Mercury before it gets obliterated by the sunlight. So that means basically you have to hit it right around beginning at about 5:50 in the morning, 5:45 in the morning. And then already by this point, by about 6:20 or 6:30 in the morning, you can't see it anymore because the sun is so bright. Somewhere in here is Neptune, not visible to the naked eye. It's just too far away and dim. Let's pause this again here so we could take a little bit of a closer look at what's going on. If we turn off the atmospheric effects, we'll see that Neptune is in there somewhere. So here's Mercury, and then Neptune should be in there, but it's one of those things, it's so dim that you really have to kind of use the search window to find it. And there's ways of adjusting it so you'll always see the planet. There's Neptune. Very beautiful, very weird, very blue planet. It's actually upside down. It spins backwards. So astronomers believe it was hit by something big time that turned it completely around, because it's the only planet that, wait, is it the one? No, maybe it's Venus that's turned completely upside down, and this thing is spinning sideways. But in any case, it has I think I'm mixing that up. Yeah, Venus goes backwards and Neptune is on its side, or the other way around. I forget how it works. Here, for example, is a big moon, very bright moon of Triton. Unfortunately, at magnitude 13.59, I'd have no way. My telescope's rated to go down, meaning more positive, to magnitude 13. And that means I pretty much can't see it because I'll never be under the best, most optimal light conditions with everything working just so. I think I should be able to go down to magnitude 9 or 10, no problem, which means that Uranus itself, though it would be a tricky target, you'd have to be in a very dark place at magnitude 8 and very blue. I think this would be a great target, but it would look just like a little tiny blue dot, so it wouldn't really be all that exciting. But if you did spot a blue dot and you could eliminate it, all the stars and things around it, then that's a great target as well. So yet another invisible thing to the naked eye, and you'd need a pretty decent telescope capable of going down to magnitude 8 to see that. And again, Neptune is very far away and lit up as a face, because if you think about it, there's no way Neptune can come between the Earth and the sun. It's an outer planet. Jupiter and so on can never be, we can never see a crescent version of those planets. At best, we might see, oh wait, is that true? I'd have to think about that, but yeah, you can never see a thin crescent. You'll see a slightly crescent version at worst case, now that I think of the geometry of it. But you'll never see a thin crescent, because that would imply that the planet is between the Earth and the moon and the sun, and that's impossible. So Neptune is also another one principally lit right now. Then we have Venus, and we can look, I think we looked at that before. Venus has no moons. Then we have the sun. So what's kind of exciting is every dawn, we have these 1, 2, 3, 4 visible planets coming up before or with the sun. Venus kind of rises with the sun. And then there's a fifth planet we can see with the naked eye, Mars. and of course the moon. So if we continue, and I'm going to do this a little faster now, we can watch for things. Now, because the sun is up, we actually can't see these things. Here comes Uranus. Then I believe we have the moon. Oh, there's Mars. And now the moon is actually far enough away that it is past Mars. Up until a little while ago, it was before them. But we can't see any of this stuff because the sun is up, and it actually looks more like this without the things. And so similarly, what we want to do is we kind of want to think of the time after dusk as a good way of not seeing the things. Like right before dusk, you're not going to see these things preceding the sun. Best time to see those is before dawn, when the sun is still down. And similarly, to see the things following the sun, the best time to see them is just after dusk or just after sunset. So here, for example, this would be an awful time to look for Mercury, because actually with the sun, you're just not going to be able to see it. If we turn off the atmospheric effects, we'll see we have to wait until, or if we turn on the atmospheric effects, that's a better way of looking at it. We'll see we have to wait until considerably after the sun goes down. And let me hurry that moment. Okay, now it's getting interesting. And now we basically see sunset, and we can see way back here. We can't really see, well, I don't want to go too long. Somewhere in here is Uranus, but with this much light, you're not really going to be able to see it. The moon is going to be kind of interesting even at sunset. You'll be able to see it with the naked eye, and it'll look pretty cool, though not as cool as a little while ago, because it's already approaching a half moon, first quarter. It was just if we go back a few days, which I'll do at the end of this video, we'll see what it looked like in the days following the new moon, when it was just a tiny little sliver. So we can appreciate the moon as being kind of moving very quickly and changing in its phase very, very quickly, unlike the planets. So let me continue the play, showing things setting. So now that it's kind of getting dark, very briefly here, you might have a chance of seeing Uranus, but it would be, where is Uranus? I think we have to turn off the sky. Wouldn't it be nice if there was an actual button where you could turn off the sky? There it is. So there's Uranus right there, the blue planet. And we can see it. The best time to see it is just before it sets. Now, what's really unusual about this configuration, and what I love, here, let me turn on. Yeah, see, this is still while the sun is putting out a lot of light pollution. It's really here when you start to get to astronomical twilight, close to it. This is about 7:30, more like nautical twilight. Astronomical twilight really doesn't kick in until about 9:30 or 10. And by then, Uranus will have set. But this is the best time frame, let's say about 8 p.m., where you can catch Uranus just before it sets, when the sun is dark, nice and dark. Look at all those crazy satellites going around at this time scale. So then there's not much happening until Mars. Mars is near Aldebaran, so Mars has a magnitude of 1.18. Aldebaran has a brighter magnitude of 8.85, and because it looks like Aldebaran is a little bit on the reddish side, you might confuse it for Mars, but they should be right next to each other in Taurus. Then we have the Moon, magnitude minus 10.80, which means incredibly bright. And in fact, the Moon will be putting off so much light pollution, it makes it hard to see this. We mentioned Uranus. And then, this is what's weird. There's nothing else. There's nothing else of interest along the ecliptic. I calculated the angular distance between Mars and Saturn, the first real visible thing to appear, forget Pluto, and Moon has now moved out from this collection, as being about 120 degrees. 120 degrees is about a third of the ecliptic. It's just under, it's like 119 degrees or something. But you can think of 120 degrees as a third of 360 degrees. So all of that magic stuff is within a third of the ecliptic. And in fact, if we rewind, there's going to be a point every day when all of that stuff is visible, and then there are no planets. Forget the moon, because I'll explain what the moon does in a moment. There we go. So basically, there's a point at which all of these things, let me turn off the atmosphere. Yeah, see, like right here, we have everything from Mars to Saturn in that 120 degree range that I'm talking about. Then you can see everything is aligned between Saturn and Mars that's of interest. The 5 ancient planets that we can see, and also Uranus, Neptune, and Pluto. Plus also notable stars in there, like I mentioned, Theta Capricornus, and this other one, Aldebaran, near there, near the ecliptic. So there's all kinds of fun stuff to look at along the ecliptic, but only during the day. You'll only see, only during the day will those things appear in full, and then you can't even see them. So I love it for the fact that there's this daily march of magic going across the sky, and you can't see it. So the only time you can see it is if you go out knowing, you kind of think of making a sky chart and then cutting it in half, and everything preceding the sun, you'll be able to see at dawn. And that's more exciting because there's more targets. Saturn, Jupiter, Neptune, Mercury, and then those notable stars like Theta Capricorn. And then after, oh, and Venus, I forgot Venus, Venus would be really stupid hard to see because it's so close to the sun right now. And you also have to be very careful not to burn out your eyeballs by accidentally looking at the sun with binoculars or a telescope. You got to be very careful against that. And then after the sun, what we have here is, it used to be a little more interesting because the moon was more involved. So you'd have the moon, then Uranus and Mars. But the moon, I calculated it the other day, I believe moves. So if we take 360 degrees and we divide by 28 days, that's roughly 12.86 degrees. So, but it's about 12, almost 13 degrees that the moon jumps every day. And these major marks along here are 5-degree measurements. So you can see that where the moon is today, if we count back 12 degrees, it was roughly here the night before. And we can verify that very quickly by just going to our time window, date time window, and simply taking, this is one, let me stop time. This is one, let's make it an exact time. So let's make this exactly, let's go a little earlier and make it exactly 1 o'clock tomorrow. And we'll see that as we go back by days, the moon is going back. See, the sky is moving for a reason I won't want to go into, but we can basically backtrack to where the moon was. So if I go back to, and I could show you that window, but it takes too much to switch back and forth. So Saturday, March 13th, 3:21 a.m. So we can do that. We can punch that up. Saturday, March 13th, 3:21 a.m. And if we search for the moon now, moon, we will see it's kind of like directly lined up with the sun. And if we go in here and we look at it, there's no illumination coming one way or the other. So this is like a perfect new moon, the astronomical instant where it's, I don't know how to explain this, where there's least angular separation, I believe, between the sun and the moon, or it's least illuminated is another way of saying the same thing. And there's all kinds of great controls you can have with this thing, which I won't get into. You can set your location here, which I'm going to want to adjust to be Shauna's balcony, which has somewhat more precise coordinates than are being shown here for Prescott, which should include 1638 meters above sea level. You could basically type in any major town or city. You could set the time as we saw. What's really cool is we can set various things in the sky that we want to see. I tend to like working minimally with just horizon, ecliptic plane, suggestion of the constellations, sometimes with the boundaries. You can turn on all kinds of other things, like, for example, you could turn on the azimuthal grid or the equatorial grid and so on, which gives you kind of a grid over the whole thing. These tick marks here say, in addition to the thing, I want to see 5-degree increments, and I also want to see, this last thing here gives us actually degree markers. So I don't want to see degree markers on the ecliptic because they're kind of meaningless. Or I guess the sun is probably at 0 degrees along the ecliptic, so maybe it's not so meaningless. If we go back and look at it, Oh no, the sun isn't at 0 degrees. The sun is pretty close to 0 degrees. So the ecliptic is more or less defined with the sun at being 0 degrees, but not quite, because it's a mean thing, which changes year by year. So that's why it's not exactly 0. But we can see here kind of an estimation of where the horizon is. And at this time, the actual new moon, all of this was below the horizon, so we wouldn't be able to see it. This is what it would actually look like. The Earth would block it out from the northern hemisphere. So here we see the actual instant of the new moon. And then from there, day by day, the moon would be trotting off 12, almost 13 degrees at a time per day, per night. But basically, this is a wonderful program, which Shauna has already fallen in love with. See, there's that string of pearls I was talking about. This is at the exact moment of the Pisces new moon, when all of this stuff was below the horizon, but magically occurring at the new moon. And then if you go day by day, or hour by hour, you'll see that if we actually turn on, let's leave the atmosphere off, but turn the horizon on, we'll see if we're looking for where the ecliptic rises, which is roughly in the east. Here's true east. So if we just watch along here, what we see first is Antares, the main Alpha, I believe that's Alpha Scorpio, the brightest in the Scorpio constellation rise. Then shortly after that, you kind of want to be watched. This is day by day. This is not just on this day. Day by day, oh, that's way too fast. Day by day, you then see Sagittarius rising, and A star, that supermassive black hole, or the super hole as I call it, that you can't see, is in here. It's great also at this time of day. This is 4:15, 4:30 in the morning. You'll start to see satellites and things very visibly. So now we're waiting for the first real planets to rise. Saturn will be the first. And I was kind of quizzing Shauna on what the order is. She's starting to remember now from seeing the simulations. So Saturn comes up first, then Theta Capricorn. Let's go a little closer. So Saturn is first to rise. You can get the rise time here, 4:45 on this particular day. Theta Capricorn, 5 a.m. Jupiter. Then, oh, I forgot, Pluto was in there, but let's forget Pluto. Then Mercury. That's the really hard one to spot, primarily right now because we have a building in the way, but it's just a matter of getting out there for the particular 40 minutes when you have any chance, when it's risen high enough and before the sun kills any opportunity of seeing it. Then in here somewhere is Neptune. You'd have to, here's another nice bright star, magnitude 3.7, so quite viewable. Neptune is in there somewhere. Then the sun and Venus rise together. Okay, Venus would be very hard to spot, and unless you have the right equipment, you don't want to be looking through binoculars or a telescope at the sun. A very good thing to do is with binoculars, just look through one eyepiece, projecting it against the wall. Just put the binoculars on a tripod or a steady place somehow, and then just project it against the wall and then look at the wall. So that's a great way to look at solar eclipses or at the sun, is just by setting. You also have to be careful not to melt the inside of the binoculars by having it off angle. So as long as the binoculars are aimed straight at the sun, so the image of the sun goes out the back and doesn't collect inside the binoculars. Don't come to me with melted binoculars if you do it wrong. You have to do it right, or just don't do it at all. And we have basically Venus and so on and so forth here. So all of this is in a hope that Paula and others, here's Uranus, sorry if I'm mispronouncing it, rising. So it's all in a hope that that those who see this are excited to go look at these things. And then right around Mars, this is something we've already looked at. We have all kinds of really cool targets that we'd like to look at initially with the telescope. Pleiades is very, very easy to spot. It's a cluster associated with nebulosity, technically speaking. That's the category, because there's also globular clusters and open clusters, open star clusters. I don't understand the difference between open star clusters and globular clusters, but there is a distinction. And this is just a kind of a loose cluster of things, just because they're all kind of in this same region where there's a nebula of some sort. You see it kind of makes it pretty because of the gas that's in front of these bright stars. So there's kind of a cluster of stars right there, and then in front of it is some kind of nebula. So it's kind of a pretty place, otherwise known as the Seven Sisters, because there are 7 principal stars in there that are known to the ancients. But if you look more closely, there's actually a whole lot more stars when you get into it. And there's actually a bunch of things in this range here that are kind of interesting looking. There's a bunch of clusters of stars in Taurus and so on. So, the other thing I haven't turned on is deep sky objects. So you have all these crazy things here. This is known, this nebula up here in the, here's the Pleiades deep sky object, but this is all part of the Maya Nebula. And Maya is the nebula I was kind of marking as something we might want to look at. Each of these is something. So this is a interstellar matter kind of bright spot. This is another one. You can kind of turn on the deep sky objects, DSOs, and then you get these little green markers, which oftentimes make very interesting things. Like this is a magnitude 6.5, therefore doable variable nebula. And when we go in here, here's kind of a look at what it might look like. It would help if I had an ocular setting so I could show you exactly what it would look like in my telescope. It would not look near this resolved. It'd probably look more like that or so. I would actually have to think of, you know what, I can tell by looking at Jupiter. So if I bring Jupiter up in the window, I could tell you roughly what we'd be able to see. Yeah, we'd see kind of like this. So my telescope goes down to about 0.3 degrees. This is roughly what you would see. So if we go back to that Maya and we aim for the similar magnification, 0.3, yeah, this is what we would see. Kind of like this in I don't know if you can see with the mouse, but this circular area. And then there's just basically tons of stuff you can look at. You could spend all day exploring. And this, Shauna's been getting very excited looking at this, like, ooh, can we see this? Can we see that? I'm like, yeah, but we have to get to darker spots. See, here's the Flaming Star Nebula. You just go, flitting about at any given time. I was advising Shauna to go after the messy objects in the sky, referring to the Messier catalog, namely M1, M2, M3, and so on. Hubble's variable nebula, magnitude 9, so pretty dim, hard to spot, kind of small. What's this? Eskimo Nebula, also hard to spot. So we might want to set it so that we're not seeing hints of things unless they're pretty bright, and then focusing on those things first. The Beehive Cluster, that sounds cool. I don't know exactly where it is here. Beehive Cluster. Yeah, let's center that and take a look at it. So that's higher up in the sky, near the ecliptic. So there's a whole lot of clusters, and they're just basically clusters of stars. Going back to my field of view, I would see it kind of like this, 0.3 degrees, I believe. So actually my telescope would be able to zoom right in and see a portion of that cluster, and binoculars would be probably better to see that cluster more fully, except for the loss of light. And then, bright stars. Stars are kind of boring because they're just points of light for the most part. The Virginids here indicates a very weak radix of 2 to 5, on average 2 to 5 meteors coming in from that direction per hour. And there you have it. And what's really weird is after Mars, this is what's really strange. This is what's happening in the sky tonight. After Mars, because of the way everything is bunched up in the sky, which is phenomenally rare, I think, you don't really get anything until about 4 or so in the morning, when you start to see, we're now at 11, there's midnight. Here's where Antares rises, and then we start to see all of those. Let me turn off the deep sky objects because now they're annoying. There's Sagittarius A star. Here comes Saturn, then Jupiter, then Mercury, then Neptune, then the Sun and Venus. So basically the fun stuff happens right in the morning, And then if we wait long enough, let's let the sun go all the way across to sunset, then we'll see the things trailing. So it's kind of fun for me to think there's all this magic occurring here that you can't see because the sun wipes it out, and the atmosphere, life-giving though it is kind of a downer for astronomers because there's all this cool stuff we could be seeing if it weren't for the fact that we had to breathe. So basically up here we have the sun setting, and this is kind of fast, so I'm going to slow it down a bit. As the sun sets, we start to get more of a view where now we can see, as the sun sets, we start to see Uranus. Uranus is in there somewhere. There it is, Uranus, the blue one. Then Mars and all these cool little things. Then the moon. Then we hit that vast expanse where there's nothing happening again. Okay, so that's it. That's all I really wanted to show you. You kind of want to download and install Stellarium. And we've also been experimenting with the Android version of Stellarium. Same program, but built for Androids. If you have a compass sensor and tilt sensor, it'll show you, if it has a compass mode and the ability to sense tilt, you can actually put it up to the sky and erase the sky and see what's up in the sky, or erase the ground, which is kind of cool. It costs, unlike the Mac and Windows version, Stellarium for the Droid costs $20 per install if you want to go for the thicker, beefier star catalog. You also want to make sure you're going to be able to install maybe upwards of 500 megabytes or more. I haven't actually researched what the actual footprint is. We got to get Shauna to install it on her cell phone. But even if you have a family plan, which we have set up between Shauna and I, the application is free and they get you as it's an add-on per droid. It's not one time for the family. So if you have like 3 droids in your family, that's $60 to enable all the features. So I think we're at the point where Shauna's going to want to install this just to be able to have a nice deep catalog of stuff available on her phone anytime she wants. And then she also has the free version available on the Mac or Windows, or even down to Raspberry Pis, but they can only do, Raspberry Pi 3 can only do about 3.5 frames per second. But if you have a nice machine, you can see it's delivering 23, 24 frames per second. You'll get nice resolution. And there's source code available for this too. So one of the things I have planned for way down the line as I write DSP software in a new language is take the core components of the rendering here and plug it through a DSP engine, and then maybe get back upwards of 60 to 90 frames per second no matter what you have turned on. Get up to 60 to 90 frames per second on even the slowest hardware like a Raspberry Pi. Orion. Let's talk about some of the fun stuff in Orion that you can see. And here I'll turn off the atmosphere so we can see it all. You've got this little lovely cluster of things down here. I don't know what it's called, but you got a nebula down here. No, that's a star, Beckled star. I don't know what the nebula is called. You got a little cluster here. You've got all these cool little stars. There's just like a huge number of stars aligned in the belt. You got another nebula down here. I mean, it's just rich with stuff. And then as I recall, if you go up here, no, that's not it. Here's the Pleiades. Pleiades? Yeah, these are the Pleiades right here off of Taurus. Okay, you've got the Pleiades off here. So coming off of Orion, which is really good, real easy to spot. So yeah, let's pick one of these stars. You can see it rises at about midnight. No, it rises at about 12 p.m., gets high in the sky by 6 p.m., and then sets at midnight. So this is something you'd want to see in the evening. So if I turn on the various effects here, we can see going towards the evening on March 22nd, which is in the future, we would see, oops, here's now. Okay, I accidentally hit now. So now we're back to March 19th current time. But if I go forward and I look for Orion, we'll basically see there's a time after which, here we go. The sun is in Pisces, I believe, still. Yep, there's Pisces. So Aquarius is going to set, followed by Pisces, And then if we go back a little bit further, we'll see Orion is following it up here. So let's allow that to occur. There's Taurus and there's Orion. So here's the sunset occurring. And when it gets dark enough, after sunset, basically you can go in and start hunting for all these things. Okay, so if you go back, if you look in the night sky for the moon tonight, this is 7:51 p.m. Mountain Standard Time on March 19th. From the moon and Aldebarans and Mars, which are all kind of together, go this direction. You'll see the belt of Orion. You'll see the little, whatever this is, the sword sheath or whatever, down here. And if you actually look in more detail, you'll find all kinds of cool binocular and telescope targets in this field of view. Here's another nice little nebula that spans a whole section of the sky that would be fun to see. So we really have to get to a dim spot with the binoculars and the telescope, and invite friends like Paula to take a risk and come with us, since I'm not fully vaccinated yet, and she probably isn't either. And go and find these things. Gemini's become a favorite target or favorite thing for Shauna to think about, simply because it's so cute. It's got the twins holding hands. Holding hands? Yeah, the twins locked in arms. So these are all great targets to look at. And with that, I can finally say, Blind Man Bert signing off. Thanks, Paula, for listening to some of this, and I'll talk to you later.